Both those who design smart cities and those who own and operate buildings will place demands on the building industry, so it must be prepared. We are currently living in the age of smart cities, which are built and connected to meet the needs of the people who live and work there, despite the fact that cities have naturally evolved for thousands of years. Building integrated structures and intelligent cities. Sensors in smart cities and buildings can detect and monitor traffic, air quality, infectious disease risk, and many other parameters. City and facility managers are able to make better decisions faster thanks to AI-powered data analysis, which ultimately helps to increase sustainability, reliability, and cut costs. Architects and planners can also draw inspiration from existing buildings and urban areas when creating plans for new construction. Adopting big data will empower and simplify green building in a variety of ways in the coming years. Green construction is becoming the norm in every country and sector. That suggests that it is now appropriate for all construction firms to implement it. We must remember that the infrastructure we construct today will still be in use in 2050, when the majority of the world aspires to net zero carbon emissions. Together with cutting-edge building technologies and digital tools, green construction will evolve and thrive. When data is at the core of every initiative, the need for sustainability is no longer a barrier, but rather a catalyst for development and financial gain. Identify and utilize additional resources. Steel and concrete account for the majority of a building's carbon footprint. As a sector, we need to embrace diversity more. Alternatives to conventional materials. For instance, bamboo is increasingly being utilized in place of wood as scaffolding in some places. In the interim, it is important to stay current with advances. Researchers in the UK have created concretine that has been enhanced with graphene, requiring much less concrete to achieve the same level of structural performance. Once more, data is essential for making decisions about the materials to use, including whether they can be reused in the future. We must first think about the end goal, because more than half of demolition materials end up in landfills. Examples include DFMA and prefabrication. Prefabrication, according to 53% of industry professionals polled for a digital sustainability study, has the greatest potential to reduce carbon emissions in the construction sector. Off-site prefabrication allows for precise planning, keeps projects on schedule due to its predictability, virtually eliminates waste, and guarantees flawless quality assurance, because components are built to exact specifications. The meticulously planned production process results in fewer construction teams working fewer shifts, which has additional positive knock-on effects that eventually raise the level of site safety. Prefabrication in sterile, dry settings lessens the risks and issues brought on by moisture, squalor, and other dangers. The 4D integration that BIM tools can offer has strengthened the design for manufacture and assembly DFMA engineering processes. Emphasis on end-to-end simplification. To protect the environment and the communities where we operate, the building industry needs to standardize sustainable building practices. Construction methods will eventually be improved by green building. Naturally, it is also a way to meet the growing demand for environmentally friendly structures from both the public and private sectors. In fact, the market for green construction is expected to be worth billions of dollars by 2030. Strategic planning and knowledge of the potential of upcoming green construction technology and procedures can help businesses get ready for a sustainable future. The emphasis on whole life emissions is being raised. It is time to analyze emissions from large-scale projects and take into account emissions after handover. When creating a developed asset, take emissions into account along with all other possible outcomes, such as eventual demolition. 3D printing and increased use of robotics. Any building's green credentials can be greatly improved by robotics. For instance, it can reduce concrete consumption on site by more than 2/3, which ultimately results in lower emissions. Additionally, it can lessen the need for wood and other carbon-intensive products, while lowering risk on the job site. The need for upgrades and modifications is growing since high-quality, climate-responsive materials were frequently used to build older structures. Renovations frequently use less new material than new construction. Renovation projects were frequently thought to be less profitable by construction companies prior to increased budgets and public sector rewards. The Renovation Wave 18 initiative was introduced by the European Commission in 2020. The plan is to prioritize whose objective is to provide tools and guidance to assist in doubling the rate of renovation of EU buildings over a 10-year period, resulting in the rehabilitation of 35 million properties during this decade. Renovating public buildings, tackling energy poverty and the worst performing structures, reducing the carbon footprint of heating and cooling systems. Plans, especially for older structures, may be insufficient, out of date, or omit vital details regarding the building's current state. By creating precise digital blueprints, such as BIM models that are packed with data, owners can more effectively plan retrofits. In conclusion, Consumer Trading Organization Limited will continue to host more concepts.